Welcome to C++ with Miyoshi. Talk about vectors today. Vectors are a way to store a bunch of data with the same name, same type, and have them have the same identifier name. So here we have, well, first of all, you've kind of used them already if you've used strings. So if we think about strings, I have string fortune here, and it says, what is the NEK? And we know that each of these elements in my string is numbered from 0 through however long this guy is, -1 actually. So there's going to be the 0 is the 0th character is the W, capital W. The character in the 1 spot is the H. The character in the 2 spot is the A, and so on and so forth. So we've kind of seen arrays before. Now, why would you use an array? Well, let's think about this. If I have these high scores that I want to keep, or I have scores that I want to keep, if I do this, int score 0, score 0, 1, score 0, 2, and so forth, if I have 10 scores or however many scores I've got to have all these different variable names. Well, arrays let us, vectors help us to keep those with one name. So here I have these in my memory. If I think about this, here's my identifier name. I have score 0, 0, score 0, 1, etc. all the way through, and I have however many I want. And then I put the scores there and so forth. Well, with a vector, I can change this a little bit. So let's just change this. I can have them all now have the same name with these little subscripts. And I just put these little subscripts there. Now they all have the same exact name, but they just have different subscripts. I'm off the screen. I am off the screen. That's okay. So I have these. So after I do that now, I have the same name. So all these guys have the same name, score in this case, or actually, if I stick with the same one I have there, I have scores. All these memory locations have the same name. They just have what are called different subscripts or different indices. And they have different values in them. Or they may have different values in them. In this case, they have different values in them. So that's the value. You get to have one name, but many things in that storage, in that name. So here we have a couple examples. So this is how you use it. I have my include vector. And then I have this using namespace std. Now, if you don't do that, every time you use vector, you have to put this std : in front of vector. So I would do this, and then this would be, all this stuff down here would be in my main. I didn't put the main up there, but they would all that stuff would be in the main. Okay? So then I do a vector, and they have this little triangular braces. The point or pointy braces, whatever you like to say. I like to call them triangular braces. Triangular braces have int. The data type goes in there. Now it can be any data type you want. So it can be ints, floats, bools, it could be strings, it could be chars, it could be whatever you want. It could be a structure that you created, but you would put the data type inside those triangular braces. Okay? Then I have my name of my identifier, just like I do with any other name. It's got to be follow all the identifier naming rules. So it's got to start with a character or an underscore. And then it can have character underscores or numbers in them. And then in this case, I also want to go ahead and initialize it. Now, if I want to initialize it with the assignment statement, I put these curly braces there, and then I put whatever I want in there. So if I wanted to have 10 scores in there, for instance, I would do 10, 9, 8, however many I've got there. Same thing with my vector float vector. I've got health NPC in this case, and then I do assignment value, curly braces, and then I put in my values separated by commas. Okay. Now, if I don't want to, maybe I don't want to assign them or initialize them when I declare them, so I could just do that just like I can with any other variable. I do my vector, my data type inside my triangular braces there, and then I call it, in this case it's a bool, and I have my name of my variable there, or my vector, and that's called bin there. Now in this case, I can do something really cool. I can use this bin there dot assign, and we have used the dot already, the dot notation, and that just tells us we're using what's called a method. But this says I'm going to bin there dot assign. That says, hey, I want 25 elements in my vector, and we're going to set them all to false. So, and if this was a an integer, I could put those as a specific number. If I was a string, I could put them as a specific string. But if I want to assign a certain number a specific value, I can do that with this .assign method. Okay? And that's a really great thing to be able to do. All right, so, and there's another thing you can do. You can access the data in the arrays, or in the vectors, by this square bracket notation. Okay, so here I'm using the same vector for my scores up here, and I have this, I make a loop. So I do for int I 0, I less than 10, I plus plus, and then I have my curly braces, and inside there I do scores, square bracket, I square bracket is assigning the value 100 minus I. So in this case, all I'm doing is assigning the value 100, 99, 98, 97, down to 91 into my scores based on their index. So score sub 0 in this case, score sub 0, that would be 100. This would be 99, the 98, the 97, 96, 95, 94, and all the way down until we get to the I sub 9, which should be 91. Okay? So that is, yeah, let's put that there, 91. Okay? Now, I could, once I assign those, I can also access them by doing this, like this case I do with printf. When I access them, I would suggest that you use the size of the array when you want to access them to get output, or if you want to change individual parts. I can do something with this as well, and I can do that in a minute here. But if I do for int I is 0, I less than scores dot size, this will go, as long as I make sure it's less than, it will go to the last element in the scores vector. And then I do the I++, of course. And here I just go ahead, and all I'm doing here is I'm just accessing the scores and printing them out. But say I wanted to change the scores to, maybe I want to do scores I, and I'm just going to add, well, assign the value scores I plus 10. Maybe I want to give a little fudge factor there or something, but maybe I want to add 10 to it. Then I can do that with the same notation. Scores I is assigned the value scores I plus 10. So this would give me not just this, it would actually increase the values in my memory, and then it would output it. And it would do that in this loop, and it would do that very quickly. Now, you can access the values in the array. You can access each array element by this square bracket notation, or you can also use this .at notation. And I've shown over here, if I replaced this guy with this guy, scores.at I is assigned the value 100 minus I. I could do that. I can also do this the same thing with the printf. I could do scores.at with the I in the parentheses there. So that's kind of a nice feature, and we've seen that. Have we seen that before? We've seen that before with strings as well. So it's consistent with the strings in that case as well. So one last thing about vectors. If you have an empty vector, you can do vector int test, for instance. If I want to now put a single value in there, and I could do this over and over again, but if I want to put that single value in, I can do test.pushback, open parentheses, 1000 for instance, and then close parentheses. That would actually put in a single value there. And then what I would probably do is I would do something like this. I would put it in my loop. I'd put it in a loop, and I would push back whatever I need to push back. And that works really well. Instead of just changing the values like it is here, pushback puts it at the end. Now, if I push back something else, if I did scores.pushback, it would now make my scores a little bigger. it would make the vector bigger, and it would put the value that I have inside my parentheses, it would put it at the end. So if I did a pushback on the scores, it would stick the next one here and make the size of it actually a little bigger. So anyway, vectors. Vectors are a great way to store multiple data in the same identifier name using different subscripts, but it's a great way to organize your data, whether you are using whatever type of data, ints, floats, chars, booleans, your own structures that you've made later on when you start using classes, those kind of things, but they're a great way to store related data in a nice, a single variable name. So that's vectors, a little bit of introduction to them and how to use them. Thanks for tuning in. We'll see you next time on C++ with Miyoshi.